All right, so this lesson is going to come in two parts, 4.2. We're talking about quadratic functions. All of this you've seen in Algebra 1, but I don't know how far in depth we went when you all were in Algebra 1. So regardless of how much you know or remember, we're just going to go back over all of it again so that you feel pretty good about it. So a quadratic equation is anything that has x squared in it. Is going to make it quadratic, assuming that that is the largest term, and we'll kind of delve into that a little bit more later. There are a few different forms of quadratic functions. Like we had some that were y equals ax squared plus bx plus c. There are some that look like y equals ax minus h squared plus k. Notice that both of these have an x squared component. The second one has like x with a squared on the outside, but it still results in x squared. So either one of those is going to be a quadratic equation. And quadratic equations, or quadratic functions, either way, make what we call parabolas. And parabolas are that U-shaped graph that you might remember from Algebra 1. So they would look like this. They can open up or down. They are symmetrical. Mine does not look very symmetrical, but it is. There are a few parts that we need to remember. There is obviously the parabola itself. We've got this line that should go directly down the middle that is called the axis of symmetry. And because it is a completely vertical line, we normally write it as an x equals line, meaning that we call it x equals wherever it crosses on the x-axis. We also have this point, this lowest or highest point, however we want to call that, which is the vertex. And I say highest because parabolas can open the other way also. So like if a parabola opened upside down, then that would be a maximum point, where in this case the vertex is a minimum value. And then we have... Let's see, we have a y-intercept. That's obviously where we're going to be crossing the y-axis. And then we have this last part that are called roots or solutions or x-intercepts. There are 4 different words that go for it, and it's where this parabola is going to cross the x-axis. There should always be 2 spaces, and we'll talk about when there isn't, but these are called, if we list those out, solutions, roots, zeros, and x-intercepts, and you're going to hear all of those words pretty much throughout the year here in Algebra 2. All right, so for quadratics, there is a parent function, and that is, remember, parent function just means the simplest version of whatever formula we're talking about, or function rather, family. So our parent function is f of x equals x squared. That's the most basic function. And if we create a table of values, there's a few things that you could see, but the first thing I want you to know is that the parent vertex is always going to be at 0, 0. That's the standard place to start. And then quadratic functions, we said, make this U shape, so it's not like it grows the same amount every single time, right? Like it's definitely steeper towards the end than it is in the very beginning. So if we talk about what that pattern is, it's not constant, but there is a pattern there. And if we look at the table of values, I just want you to look at this pattern. So notice, remember, this is x and y, and we do like rise over run. So on the run category, notice I'm just going up by 1 every time. So I'm just going to run 1 every single time. But in the rise side for the y values, it's not a constant rate, but there is a pattern here. I'm going up by 1, and then by 3, and then by 5, and then by 7, and hopefully you see the pattern there is that we're counting by odd numbers. So the parent function starts at 0, 0, and has the basic pattern of 1, 3, 5, 7. And all of that is going to be over 1. So if we graph what that looks like, I'm going to go ahead and, here I'll zoom in so you can see it a little bit better. All right, I'm going to start at 0, 0. I'm going to go rise 1, run 1, rise 3, run 1, right? 1, 3, rise 5, run 1. And then if I had room, obviously I would rise 7 and run 1. So on this other side, I'll just map that out, 1, 3, and then up 5. All right, and then we're going to mirror that on the other side so we get our parabola shape. So up 1, up 3, up 5. And that is going to give us, when you connect, that's going to give us this nice pretty U shape. All right, so there's our parent function, our most basic function. So let's look at what happens when we apply some transformations to that. All right, so we're going to practice 2 examples while we're in vertex form using transformations. So very similar to the way that we did with absolute value. We want to start with the vertex, which we know comes from addition and subtraction. So we know and I'm going to be using these numbers. Inside's the opposite and outside's the same, so that's going to give me positive 1, positive 4. And I'll go ahead and graph that, positive 1, positive 4. And then we know that multiplication, so this negative 1/4 out here is going to change a few things. One, the negative is going to reflect, which means my parabola is not going to open like the U shape anymore. It's actually going to open upside down. And then the 1/2 is going to change my pattern. So on the outside, right, we're nodding our head up and down, so that is vertical change. Up and down means I stay the same, so that's 1/2, which means I'm going to end up being a compression vertically. So the way that this is going to change my pattern, so remember my original pattern is 1, 3, 5, 7 all over 1. So vertical, up and down, means I'm going to be changing the rise component. And I'm going to change all of those by a multiplier of what I've been given. So my vertical compression of 1/2 now means my pattern is going to be 1/2, 3/2, 5/2, 7/2. Now notice I'm only changing the rise component, so my run component for all of these is still going to be 1. So let me show you how that maps out. All right, this time I'm going to rise. I'm going to zoom in so you can see it a little bit better. All right, I'm going to rise 1/2, but still run 1 whole run. Now I'm going to rise 3/2, 1, 2, 3, and run 1 whole run. Rise 5/2, oh, and I'm going the wrong way. All right, remember this is supposed to be negative, so I probably should have written that for myself. I'm going down 1/2 and running 1, down 3/2 and running 1, down 5/2, 4, 5, and running 1. And I could keep this going, right? I could go down 7/2, 1, 2, 3, 4, 5, 6, 7, and run 1. So notice the run is not changing, it's just that rise component that's changing. And then we're going to do these matching or corresponding points on the other side so that we get a symmetrical parabola. So here's my parabola for this one. And one of the other things that we want to add is we want to go ahead and talk about domain and range. So if I zoom out for a second so that we can see the domain and range, and I've got this, sorry, I've got extra stuff written down here. So my domain, remember, we're still going like left and right forever. So my domain is still all real numbers, or we can write negative infinity to positive infinity. And then my range, we want to talk about like the highest and the lowest y values. So here I actually have a maximum of 4. So that means I'm going to be going from negative infinity to 4. And 4 is included, so I'm going to use this bracket here because it actually hits 4. If I write that as an inequality, that's just y is less than or equal to 4. All right, so let's go ahead and look then at this second example and see how it's a little bit different. Okay, so again, we want to start with the vertex, which means I'm looking at my addition or subtraction pieces. So my vertex here is going to be inside's the opposite, so that +2 becomes -2. Outside is the same, and since there's nothing out there, that's going to stay at 0. So my vertex is going to be -2, 0. All right, now my pattern, I want to look at the multiplier here. So if I go ahead and look at this multiplier, that's 1/4. That's on the inside, so this is horizontal. And inside is opposite, so that 1/4 becomes 4, which means I'm now looking at a stretch. Okay, so if I want to stretch this, now let's think about our standard pattern. Remember, our standard pattern is 1, 3, 5, 7, all over 1. That's the rise over the run. Well, horizontal is going to affect the run part. So my rise is staying the same, but my run is now going to become 4. So that's the pattern that I'm going to use. And I'm going to talk slowly so I don't say the wrong thing. All right, so I'm going to rise 1, and I'm going to run 4. I'm going to rise 3, and run 4. And then rise 5, 2, 3, 4, 5, and run 4. So notice the rise, 1, 3, 5, 7, hasn't changed, it's just the run. All right, and then same thing on the other side. Rise 1, run to the left 4. Rise 3, run to the left 4, and then we'll just connect that. And notice that this is, nothing is changing vertically, I'm just stretching horizontally. Instead of running 1, I'm running 4 every time. And then if we continue like we did on the last one and talk about domain and range, Here, again, domain, still going negative infinity to positive infinity, so domain is all real numbers, negative infinity to positive infinity. And then my range, I'm looking for the highest or lowest value. So here, the lowest point that my graph ever gets is 0. So that's going to be y is greater than or equal to, because we're going to go up forever, 0. Or if I write that in this other notation, that's going to be 0. Ooh, and I did that wrong. 0 to positive infinity. And what I did wrong was that needs to be a bracket because it does actually hit the value of 0. All right, so that's all we have for this first part on quadratics.